Welcome. This is design oriented class. See, so far we considered analysis. That is, cross section is given. Cross section given means cross sectional dimensions with the area of reinforcement. Singly reinforced means only AST. Doubly reinforced means AST and ASC along with the cover, either clear cover or effective cover given, and grade of concrete, grade of steel given. So you have to find what is the resisting capacity. Ultimate MR means resisting capacity. Remember, in limit state of strength, we consider bending. This is called limit state of strength in flexure. First of all, small information. In case of any structural member, there are 4 section forces, namely axial force, shear force, bending moment, and also twisting moment. They are all called section forces, or they will, when you write some value, any value for that matter, suppose for example, you write bending moment is 60 kilonewton meter. It means the cross section of the beam is subjected to that bending moment. So cross section has to resist it. Same for axial force, shear force and torsion. People call all these as internal. That is meaningless. They are external. If it is internal, why you should resist it? Internal means what? Already resisted. So that only is sufficient to make it clear that these are external. Separate class I am uploading later, that mistake people are doing when they call all these as internal. Now see, in IS code, we can see limit state of strength in flexure means bending, limit state of strength in shear, limit state of strength in torsion, and compression, that is axial force. So all these are section forces. The cross section provided should be able to resist it, or the cross section should have capacity either equal to the whatever section force, or it should have higher capacity. For example, if the bending moment is 50 kilonewton meter, the cross section provided should be able to resist either 50 or more than 50. Then it is safe. Okay, now we are changing now. Now you can see the title or thumbnail, or you can see different one. See, note, this is design oriented class for singly reinforced and doubly reinforced rectangular sections. I am limiting only for this one now. See, before I start all the concept, first, during design for flexure, remember flexure means bending. Design for flexure means for bending strength. Strength requirement it is. We have to ensure that the cross section provided with the reinforcement, if singly reinforced, only AST, if doubly reinforced, AST and ASC, satisfies the strength requirement in flexure. That is, ultimate MR of cross section provided. See, ultimate MR means capacity. So, is either equal, exact equal is not possible, or more than the factored BM to which cross section is subjected to. Subjected to, full stop. Why? Because statement subjected to is an English word. Okay. Subjected to. Okay. This only will tell bending moment is external. Okay, leave it now. Now, here there are 2 parts. One, dimensions of cross section, that is BD along with the D, and make a note here, and D dash, right, if applicable. If applicable means if it comes doubly reinforced section. Required, second one, required cross sectional area of longitudinal reinforcement. Remember, longitudinal reinforcement means reinforcement running along the length of member. When you take cross section, you can see the cross sectional area. So therefore, longitudinal reinforcement means if it is singly reinforced section, it is AST. I won't waste time area of steel in tension like that. If it is WA reinforced, then longitudinal reinforcement means AST and ASC. See, I wrote here AST if cross section is designed as singly reinforced section, and AST and also ASC if cross section is designed as WA reinforced section. Now, one dimension, see, this part will not be covered here. Make it note. This comes in the design part. How to fix the depth based on sometime deflection control, sometime L by D ratio is there. You have to satisfy strength requirement. There are so many parameters are there. How to fix the cross-section dimensions. That we are not covering here. It will come only in the design course. See, if I cover everything here, this will become one full course only. I am giving important information for people who find difficulty to understand this part. So, these dimensions of cross-section, that is breadth, depth, effective depth, with the D dash if applicable. This is one part right here. This comes in the course, or this I discussed. So many IS code restrictions are there, and then requirements are there. So therefore, when you come to today's class here, understood, these dimensions are known. I will little later, steps I will give you. Second one, required cross-sectional area. Why required? You should find how much is the required area. Once you know how much is the required area, you have to suitably provide it. Again, when you provide the reinforcement, what you do? You either provide equal to requirement or little more. You should not provide less than requirement. But our course is only for finding required area of steel. Then see, after getting the required steel, you have to consider IS code. Some minimum requirement is there, maximum limit is there. Then number of bars you have to arrange. That all comes in the design part. So structurally here, I can tell AST required for singly reinforced section, AST required and ASC required for WA reinforced section. This is our important. Now, I forgot one thing. Before I start any of this one note, very important part of design of beams and also for slabs by limit state method. Class means, I told all these things here. These are based on strength requirement. Our present consideration is how to find cross-sectional area of longitudinal reinforcement required. That is AST required for singly reinforced, or AST and ASC required for WA reinforced for rectangular sections. For that one, see, B, D, capital D, small d, and D dash will be given for you in the class. But during design, you have to fix it. Anyway, I will little later, when I give steps, you can make out. Now, before you go further, one important part, that is regarding bending moment and moment of resistance. See, first I will remove all this now. Right, once again, one more note I will give. I will give one more note for that. See, sometimes I will tell you, in analysis problem, we call MU as ultimate MR of the cross section. In design part, we consider, or we call MU as factored bending moment. Sometimes students get doubt. Sir, earlier you told, sir, MU means ultimate MR. Now you are telling MU is the bending moment. I will explain 1 minute. Reason I will tell you. I will tell the reason for it. Now, one very important note. First of all, note, I am explaining in simple way so that all will understand. Easily, you can add, all understand. I am not going to high level technical language. Sometime in the class, offline class, when students are there, I will ask them, shall I explain simple way so that you understand, with sometime lot of practical examples, sometime money matter, etc., vehicle driving for understanding. Do you want that way, or shall I go highly technical level? I will tell them, just because I am explaining in a simple way so that you can understand, don't think I cannot talk technical. I can talk technical, only technical, no crude method, nothing, everything technical. They always shout, sir, no, no. I will tell, in that case, what will happen is, tomorrow so many from here will not come to the class. They will tell, hey, he is telling something. First of all, he doesn't know what he is telling. See, a good teacher, he will not bother about high level, low level, or etc. He should deliver and make those who are learning fully convinced. Then if they want to go to high level, they will go to high level by learning more. There is no point in going for higher level. I can go, but I am not going. Okay. Now, during flexural analysis, that is finding ultimate moment of resistance for given cross section. See, given cross section. That is actually what? Analysis. That is actually what? That is analysis. Analysis. That is breadth, effective depth, area of steel, if singly reinforced, and also area of steel in compression. If applicable means what? If singly, only AST. If doubly, AST and ASC. If applicable, along with FCK, FY are all given or known. Okay. Therefore, see, this is given cross section. It is not design case. So I wrote here, where we write when we in that case, during analysis, when we write MU, simple language, MU stands for ultimate MR for given cross section. See, because it is analysis. Analysis means cross section given. You are finding the strength. We use the term MU as used by IS code also. There, if BM is considered, it is called BM. See, some application I have done. What I did? Ultimate MR, I called MU. Bending moment, I called bending moment only. See, of course, factor term will be there. That is there. So, note, already over. So, remember, once again, last I will tell. But during design, MU stands for not ultimate MR. MU stands for factored BM to be resisted by cross section. See, there, last I will tell. Then doubt can come. Someone, what symbol for ultimate MR for given cross section? Somebody can ask this way. Sir, then what symbol you are using? See, earlier you told MU stands for ultimate MR. You are calling bending moment as bending moment only. But here, what sir? You told now suddenly MU stands for bending moment you told. Okay. Then what symbol for ultimate MR for given cross section? Question mark. I will tell what given cross section. No problem. In case of design, there is no given cross section. Cross section dimension can be given by somebody, but cross section given means full. Everything should be known. Everything should be known. You are only finding strength. There is no given cross section. Cross section with the reinforcement, we have to decide and arrange it. Ultimate MR for given cross section, that will not come there. See, the term ultimate MR for given cross section will not come in design cases. Therefore, remember, lastly I will tell some, I will write here now, I will not repeat once again. Earlier, that is final, during analysis, MU stands for analysis of given cross section. Okay. MU stands for ultimate MR of given cross section. If bending moment comes there, bending moment called bending moment only. Already over. Now, but during design case, MU stands for factored bending moment. I written same language. Factored bending moment. Where is it? Cross section to be resisted by cross section. And doubt here. What about MR? Ultimate MR will not come. Only MU limit will come. That is no problem. It will not come. So I am concluding now. During analysis, we MU stands for ultimate MR. If for application problem, if bending moment comes, we will call a bending moment only. Of course, factored is there. During design, MU stands for factored BM to be resisted. And ultimate MR, we don't consider because there is no given cross section. Okay, make that note. Now, go further. Now, what I will cover here in this course, that is part 1, part 2, part 3, etc. 4, 5 parts will be there. Actually, you have to go through all the parts. You have to combine together and make a single fair copy. I will give in parts because single video, if I make, sometime what happens is, it becomes too lengthy. So, part by part is better. Step by step understand. So, B, D, if applicable D dash. Now you know it. If applicable D dash means if the cross section is doubly reinforced. Okay. FCK, FY and also and factored BM to be resisted by cross section, that is called MU. Just now I told. In design cases, MU is the factored BM. Are all known. Class right here. Something. B, D and D dash. How to decide? It comes in design part. Preliminary dimensioning, that all comes the design part. So when I consider the examples here, I will give the value of B and D. Means you should reach that stage. Anyway, later I will tell a step there for you. During design, we will reach this step, then what to do. So that you write here. Then here we will consider calculation of required cross-sectional area of tension reinforcement and if applicable, that of compression reinforcement also. That means AST required, see short form, in future I won't waste time. SRI means singly reinforced, see it's a verb now. And DRI, if I write DRI, it means doubly reinforced. So if singly reinforced, how to find AST required, and if doubly reinforced, how to find AST required and AC required. Make a note. Required steel so that the cross section can develop capacity or resisting capacity either equal to bending moment or more than bending moment. We will make it equal. Then when you provide, you are providing slightly more, that will give more strength. Okay, now first we have to decide whether cross section is to be designed as singly reinforced or doubly reinforced. Then how to decide, I will tell you. See. How? Wait for some time. I will cover it. Then after deciding, see again time space problem, singly reinforced or doubly reinforced. Then if it is singly reinforced, we have to find AST required. Do one thing, write correctly, not AST required. Cross-sectional area of steel in tension, that is AST required to make pakka fair copy. Whereas if doubly reinforced, we have to find cross-sectional area of steel in tension, AST required, and also cross-sectional area of steel in compression, that is ASC required for the cross-section. That you have to cover. So now, little later, I am going to give you systematic procedure. It is sufficient if you follow only procedure, but these all will make your concept clear. Otherwise, doubt will come. Suddenly, why he is telling that way? So, all these parts, analysis is your choice. The design part, what I am telling, every class you have to go through, I will give in parts. You have to join them, continuously you have to write it. Don't write part 1, part 2. Start from in a book, keep on writing till this, what I have told, this part, complete course. Course means this special. Now your thumbnail will change here. Something else you can see. That everything is over. Today's is part 1. 1 minute. Once again note, when you reach this stage, B, D, FCK, FY, and factored Bm to be resisted by cross section, that is mu, are all known. And also note here, also note, I should not tell. Once we know Fy, xu max by d is also known. X max by d is also known. You can make a small note here. If Fe 250 or Fe 415 or Fe 500, you can read directly from IS code. If some other steel is there, you have to use the equation, basic equation, 0.0035 divided by full 0.0035 plus Fy by 1.15 ES plus 0.002. Fast I am telling because you know it. Okay. Now, then, okay, first these are all known. Doubt comes. Sir, you told just now how to find the AST for singly and AST ASC for doubly. Correct. How to decide whether cross section is singly and cross section is to be designed. Okay. Cross section is to be designed as singly reinforced or doubly reinforced, question mark. First, for that what to do is first find mu limit. That is limiting MR for singly, see, this is the only place you use MR, but it is not ultimate MR of given cross section. Limiting MR for, that is mu. Mu stands for limiting MR for singly reinforced rectangular balance section. That is for xu equal to xu max. Make a note, whether cross section is singly or doubly, whatever it is, that all later, right here, first right here, I'll tell you 1 minute now. Okay, now, or you can tell one more thing. Mu limit is the maximum factored Bm that can be resisted by a singly reinforced rectangular section. Singly reinforced. Okay. Now, mu limit equal to 0.36 into xu max by d into 1 minus 0.42 xu max by d into bd square fck given in IS code. Substituting, find mu limit. Now, make a note. So far, we do not know whether cross section is to be designed as singly reinforced or doubly reinforced. It will come later. It will come little later. Then whatever it is means what? SRI or dry. I should not write this way. Okay. SRI or dry. It is mu limit is required. Therefore, find it. Okay. Using the formula mu limit. So now you know mu limit. Okay, now I will write next part. See, I am writing all bold letters. Why? So that everything is crystal clear. I just now told mu is factored Bm to be resisted. Already known. And I told just now, find mu limit. So now mu is known, mu limit known. What is mu? What is mu limit? I wrote here. I already told 4 or 5 times. See it there. Okay, now. Then, 2 cases are there. I won't put case 1, case 2. Then, if your mu is less than or equal, no problem, but not more. If mu is less than mu limit, cross section is designed as singly reinforced. Then we have to find, you should write cross sectional area of steel in tension, that is AST required. Whereas if mu comes more than mu limit, next time I will give more explanation. then cross section is to be designed as doubly reinforced. Therefore, we have to find cross sectional area of steel in tension, AST required, and also cross sectional area of steel in compression, that is ASC required. See, you can make out how much importance I am giving for cross sectional area. See, structural engineering is cross section. See, neutral axis comes in the cross section. People show it in the elevation, lengthwise. Utter nonsense. No, it may be same. See, neutral axis goes this way. That is not a neutral axis, it is neutral layer or level. When you take the cross section, then you see neutral axis. So many people are rectified. They corrected now. There are lot to be rectified. I will upload a class for that one. Common mistakes committed. Okay, now one note. This I will explain for you. Reason I will explain with some money matter also, if requirement is there. Part of all not required. First I will explain technically when I go to next step. Or practical example, say money matter. Okay, now note, dictated in the class. Write if you want somewhere outside without disturbing the present discussion. Do not write anything here. Somewhere in the paper write and attach if you want. See, I will tell what. During analysis, you don't decide singly and doubly. What you decide? Whether cross section is under reinforced or over reinforced. There you compare XU with XU max. XU less than XU max is under reinforced. XU more than XU max is over reinforced. That is for analysis. But design, you don't compare XU XU max. You compare MU with the MU limit. Now, I will tell the reason next time. In the next class, I will tell the reason, because actually I need not tell the reason why. This course is only 2 steps, but I am already telling too many things now. Too many concepts I am telling. Okay, I will tell it. So I will tell the reason why it is that way. So that is only for analysis purpose. Design. Compare MU with MU limit. If MU, see, actually if you understand the meaning of MU and MU limit, you can make out logic only, you can decide. If, see here, bending moment is within the limiting capacity of singly. How much maximum singly can resist? Your bending moment is less than that one. That only will tell you what? Singly reinforced. Here, the bending moment to be resisted exceeds MU limit. Then 2 options. Either you have to go to over reinforced section. No, outrightly ruled out. So go for doubly. This I will tell systematically. So with this one, this class I am ending. I will give warning. Wait for next class. When you write fair copy, continue from this class. Everything continuously write. Do not write he took part number 1, part number B like that. Because here I do not want to upload a class of more than 30-40 minutes. So this is a basic information. Next time I will write. See, actually some will tell. Procedure. Students will suddenly get alert in the class. Oh, sir is giving procedure. Therefore, what all he told so far is only for understanding. Some students who want to pass, they will tell, we want to pass, good marks. So I will follow procedure. Reasons, okay, sir told, we agreed. And they will tell, 100% sure, he will not tell wrong things. That belief they have got on me. But next class I will give procedure for both. Singly and doubly, both I will give procedure. Then I will give numerical example. One example for singly, one for doubly, then another 2 examples. Practice question I will give you, work out that one. This part will be completed. Okay. See you in the next class. Thank you for watching.